Okay, you'll note that this is the same problem that we have just looked at in the previous module. And we calculated that Thevenin impedance by first finding the open circuit voltage, which was the Thevenin voltage, and then the short circuit current, and dividing that into that Thevenin voltage. Now you'll note here that we have one source in this particular problem, and it is an independent source. And if you remember when we were looking at what DC circuits, we said that we could look in at terminals A, B, and zero all internal sources if our circuit basically comprised of what? Independent sources. Well, the same is really true here. And so we could really zero this source. So let's just redraw this circuit with this guy zero. So what do we have? We have this 3 ohm resistor here. We have this guy here, J4. We have our capacitor sitting here, and its impedance is what? A minus J10. All right, here are our terminals, A, B. And we're going to simply zero this guy over here. That is replacing it, since it's a voltage source, we're going to replace it with a short. So the Thevenin impedance then is the impedance looking in at these terminals, having zeroed all our independent sources. All right? Now we can only do this really if we have a circuit that is made up of independent sources. All right, so let's have a look in. What do we actually see looking in here? Well, our Thevenin impedance is going to be equal to what? Well, it's a parallel combination. We've got this guy in parallel with this over here, haven't we? So it's this in parallel with this. All right, let's write that down. I'll write this down in its polar representation. What is it? It's 10 at an angle of minus 90, and that's multiplied by what? This impedance here, which is what? I'll put a bracket here. It's 3 plus what? J4, okay? And then it's divided by the sum of this and this, which is what? Well, it's going to be the 3 plus the J4, and then plus this guy here, which of course is a minus J10, all right? All right, let's take this just a little bit further here. So what have we got? We'll convert this guy to its polar form, and so we've got that Thevenin impedance being equal to 10 angle minus 90, converting this guy to polar, that's multiplied by 5, isn't it? And that angle there is a 53.13. And then in the denominator here, what do I have? The real bit is 3, and I have, yes, the imaginary bit being a minus J6. All right, now converting this into its polar form. So we've got our 10 angle minus 90 multiplied by 5 angle 53.13. This in polar is 6.7, and my angle here is a minus 63.43. All right, so if I multiply this with this and divide it by this, I get 7.46, and my angle, so bringing this up to the top and adding them all together, my angle becomes a 26.56 degrees. And so you should now compare that with the other approach, and you'll see that apart from a little bit of rounding there, that they're exactly the same. So we can use this technique here when we have independent sources in the problem.